Welcome to another maths video brought to you by Vision Concepts. Today we'll be discussing algebraic expressions. I would like to start by giving us a puzzle. Think of a number. If you add 15 to it, double the result and add the number you first thought of. Divide the results by 3. Take away the first you thought of. What is the number? Okay, let us walk through this puzzle and take the terms one by one. Think of a number. Think of a number. Anyone, any number, just think of it. Add 15 to it. Double the result. Add this to the number. We're taking it line by line. The number you first thought of. You first thought of. Okay? Divide the results. Results by 3. Okay? Take away the number you first thought of. So, what is the number? Okay. So, take a wild guess and let's know in the comment section what you think the number is. But we'll go ahead. So think of a number. Me, I will think of anything and I will represent that number I'm thinking about in my mind as A. Small letter A. So add this number to 15. This number I'm thinking about is in my mind, but I'm having it as A. So I add it to 15. A plus 15. Double the results. So this is the result. If I add what I am thinking about to 15, I'll double the result, meaning I'm going to multiply by 2. Multiply by 2. If you simplify this expression by opening the bracket up, what you have there is 2 times A is 2A plus 2 times 15 is 30. So that is double the result. This is double the result. So add this number you first thought of. So I'm going to go back and add my first thought of. So I thought of a number. This is A. It didn't change in my mind. I see have it there. So number I first thought of is A plus the result of this one, 2A plus 30. Then divide the result by 3. This one 2. I divide by 3. But I can simplify this one because A plus 2A is 3A. So 3A plus 30 divided by 3. So I will simplify this one again by dividing this term and this term by 3. So it is 3A over 3 plus 30 over 3. What I will have there is A, that is 3 cancel 3, that's A, plus 3 cancels 30, I will have it as 10. A plus 10. So take away the first the number you first thought of. So the first number I thought of is A. So I will say A plus 10 minus A. A minus A is 0. Then the number is 10. So that is the number. So this puzzle actually gives us the reality of what algebraic expression is. It helps us to use letters to represent numbers. Okay, so if A and B are symbols, I'll take this off. If A and B are alphabets used to represent numbers, so we speak of sum of A and B, the sum of these two variables as A plus B. The product, we speak of it as A times B. The quotient, the difference, first of all, the difference, we speak as it as A minus B. Quotient is dividing. The quotient, A divided by B, okay, and exponent, we see it as A raised to B. So this is how we use alphabets to represent mathematical expressions for algebraic expressions. And the rule of algebra follows what we discussed in our first class. Check out the video for numbers, basic operations, and numeration. The rules of operations. So there are the rules for algebra. The rules of algebra. Obeys commutativity. I won't go into this in detail because it's in that video. Associativity and distributivity. So these operations can be done using algebra. So I encourage you to go and check out that video uploaded already. So we will look at terms and coefficients. Terms and coefficients. Terms and coefficients. Okay, so terms and coefficients. So an algebraic expression consists of alphabetical characters and numerals linked together with the arithmetic operators. Example, if you have 8x minus 3xy. You see now, we have in this expression, we have alphabets, x and y. We have numerals, 8 and 3, and we have operation, minus. So a full algebraic expression contains variables. X and y are variables. X and y are the variables. So we actually use alphabets to represent variables inside an algebraic expression. 8 and 3 in this expression are the numerals. I will explain than the numerals, that's numbers, than the numbers. But at the same time, they are the coefficient of the variables. Coefficient means the number that is in front of the variable, the alphabet. And minus is the operator or the operation. Most of the times, we also include the minus, the operation sign with the coefficient, the numeral, to term it as a coefficient. So if I ask you what's the coefficient of xy, for instance, the coefficient of xy is minus 3, and the coefficient of x here is 8. Now, these are terms. This is a term, x is a term, xy is another term. They are two different things. Even if you have x here and x here. The combination of these two has made this one a term, and xy is not the same thing as x, because if you are doing the operation to simplify algebraic expression, I cannot add whatever I have here with this one because they're not the same thing. So a like term, that's what give us the next subject to consider: collecting like terms. Collecting like terms. Collecting like terms. So a like term is a term that is similar with another term. For instance, if I have, I'm going to be quickly simplifying some expressions here. If we are told to simplify the following algebraic expression, this question, I'm going to use it for three other ones. So number one, the first one, simplify this one. If I have this algebraic expression 4xy plus 3xz minus 6zy minus 5zx plus 4yz. Simplify. When you hear the word simplify if you see the word simplify in the question, what they are trying to tell you is that you should make the question simpler. Sometimes people are scared of this kind of instructions in mathematics. Simplify, evaluate, computate, and so on and so forth. Simplify means that you should make it simpler. At the end of what you are doing, I should have lesser terms as my answer. That is, it has become simplified. You see, I have how many terms in this expression? This is 1, 2, 3, 4, 5 terms. My final answer should be less than 5 terms. I'll make it simpler. Okay. Now, in this algebraic expression, I'm going to expect. Inspection means I'm going to look at it one by one. How many variables can I identify here? xy is a variable. xz is a variable. zy is a variable. zx is a variable. And yz is a variable. I said that algebraic expression obey the rules of operations. That is, it has commutativity, associativity, and distributivity. You see, for two variables here to be similar, they will contain the same alphabet. Even if you place them in different positions, see what happened here. This is xy, this is xz, this is zx. So these two are the same thing. I can write it so that it can look alike. Look alike, yes, to my inspection. This is 5 here. So as I'm inspecting again, I'll say 4xy, okay, plus the best practice is to also always ensure that they follow. If you have two variables in one term, that's x and y, for instance, make sure you just arrange them according to the order of alphabet so that you can easily see which one is similar. So I have 4xy, then I have 3xz, because x comes before z, this one is correct, minus, I can put it here as 6yz, because y comes before z, then I can say minus 5xz, because z comes before, x comes before z, so that this one and this one are already looking alike in my eyes. Then this one, I can put, this is y and z is correct like that. Okay, so I've arranged so that I can quickly inspect. So collecting like terms means I will look for the two or more that are similar in the variables. So xy here and okay, xy here, that's the only one that is, so I will just write that one outside. 4 xy plus, for the xz, I have these two, so I'll bring them together. So I'm collecting like 10, that's what that means. 3xz, then minus 5xz. Then I now have finally yz and yz. Minus 6yz plus 4yz. Note how we are collecting like terms. You are also moving the symbols, the operations with it. Because I said that the coefficient is actually the number and symbol before the variable. Coefficient is the number and symbol before the variable. So I collected xy, you understand, as the first term in my new line. I put xy as my new term, my new line, and I'm also taking the 4 plus 4 with it. There's a plus before this 4 here, not written. Okay, so the next one, I'm collecting 3xz. The 3 is the coefficient of xz. 3xz. So I look for its brother here that has the same xz and takes the I also take the minus sign with it, collected, and this one goes minus 6yz, then plus 4yz. So when I've collected it like this, I can now simplify. Simplification means I can now add. You can only add like terms in algebraic expression. You can only add like terms in algebraic expression. So here I have 4xy plus, okay, now before I just go, plus 3xz minus 5xz. Now when you are doing this, just in your mind, do operation on the coefficients, on the numbers, the numerals. This other xz, the variable, will be constant, will appear in the final answer. So plus 3 minus 5 is minus 2. Then I put xz. Then for this one, minus 6 plus 4 is minus 2yz. Now, by inspection, I can also do factorization. I can just group 2. This is the answer, but I can still decide to make it simpler by saying, okay, I have x here and x here, the first two terms, x here and x here common, or I can group it by the last two terms, z and z, they are common. Now, if I do the first grouping, any of the two is correct. Just if I do the first group, if I group these first two together, I see that x is common with this. I can bring it out. When I bring it out, what is left in the, I'll put a bracket, what is left in the first two terms here is 4y minus 2z. That's what is left here. Then I can now say minus 2yz. This is a simpler form. This is the simplification of this question. Notice how this final answer is simpler than this. So that's the word you look at, simplification. Or if you decide to go by grouping the last two terms, it's still the same thing as saying 4xy minus, then what is common in these last two terms? You have 2 is here, 2 is here, is common, z is here, z is here common. So it's 2z outside, then open a bracket and put what is left over. This is x here minus y there. Okay, so these two answers, this one and this one, is the same thing. You are correct, it's the same thing. You can, if you have the question in objective format where you have options to choose from, and either of these two, if present, is correct. This is simplification, but we went further to factorize by grouping and collecting a similar factor in the terms so that we can have it in a simpler form. Okay, so this is for question 1. Let me put another question for us to consider. Still simplify. Number 2, still simplify this algebraic expression. Number 2, I have it as minus 2a plus 4ab plus a minus 4ba. You see now, this has how many terms? 1, 2, 3, and 4 terms. You have 4 terms. You have 4 terms. So the first thing you do is to rearrange them so that you can easily inspect. Arranging means that if you have 2 variables in a term, ensure that they are arranged so that the first alphabet precedes the next alphabet. Okay, so I have minus 2a plus 4ab. This one is still correct. A comes before b, so I say 4ab plus, this is just a single variable, a minus, this one is 2 variables. Now this is ba, so make it 4ab. So this is minus 4ab. This is what we call known as commutativity. That means you can switch the 2 terms. Either way, it will give you the same result. A times b is the same thing as b times a. Check out that first video on numeration. My video on numeration, you will see what commutativity means. So here is an expression that you have done to arrange the alphabet in order. The next thing you need to do is to collect like terms. Collect like terms. Let me write it here. So I do that. That's what I'm doing. Collect like terms. What are like terms again? Like terms are terms that have the same variable. So 2a has the same variable as a. They said a here, there's an a here. So I collect it with the signs, please. This is 2a minus 2a. I take this one to close to it, plus a. Then this is 4ab and this is minus 4ab. The same thing, ab. So plus this first one plus 4ab, then the second one minus 4ab. Then do the operation. That's do the addition and subtraction wherever you see it. So minus 2a plus a. Just since they are the same a. In your mind, forget about the a and work on the numerals, the coefficients. Normally, if you have just a like this, the coefficient in front of it is 1. Whatever number is the number in front of it is 1. So minus 2 plus 1 is minus 1. That is minus a. Most times we don't write the 1 in front of it. If you just see a single variable without any number in front of it, you know that the coefficient of that number, that variable is 1. So this is minus a. Then this one is 4ab minus 4ab. 4 minus 4 is 0 plus 0. The answer here is minus a. So this is the simplification of this. See all these plenty terms here. You see, you have 1, 2, 3, 4. 4 terms, and it's just one term you have like that. So simplification makes it simpler, not makes it complex. When we're solving, when you arrive at something more complex than the question, you are not simplifying. Ensure that you do it until you get to the final answer. All right, so we will stop here for today.